Hello guys, this is Krishna. Welcome to part 2 of bolt session. Since the video is getting lengthy, so I thought to make it in 2 sessions. Now, types of bolted joints. For example, if you take a steel member and a bolt connecting these two steel elements like this, and this will be the threaded portion of the bolt. At this condition, the plane between these two connecting elements, we call it as shear plane. How in this picture it is shown. If the bolt threads are crossing this shear plane, we will say end type, which means threads included in the shear plane. If these bolt threads are not crossing this shear plane, then we will say X type, threads excluded from the shear plane. Now, what is SC type? In N type and X type, the load resistance will be done by bearing capacity of the bolts. But when it comes to SC type, this is a steel piece and this surface of the steel piece is connecting to adjacent steel, right? And this is also one more steel piece and this surface is connecting to adjacent steel. We call these two surfaces as faying surfaces. In slip critical condition, these faying surfaces will be prepared with some friction on the surfaces. Means they will make these surfaces little bit rough, so that when those two surfaces are getting in contact, due to that friction, there is a slip resistance between these two surfaces, and most of the load will be resisted by this slip critical condition. So this type of joint we call it as SC type. Next, bolt installation procedures. There are 5 types of bolt installation procedures. This is a conventional bolt installation procedure, and these remaining 4 types are pre-tensioning of bolts. Okay. Now, snug tight. You will insert the bolt and you will keep the nut, you will rotate the nut, and you will rotate the nut so tight as much as possible. So that is snug tight method. In snug tight method, bolt is tightened with full strength of iron worker. And next, turn off nut method. This is turn off nut method. Before getting into turn off nut method, bolts should be tightened by using snug tighten phenomena. Okay. Later you will mark how much we need to follow this degree. It depends upon the bolt size and bolt length. Okay. Depends upon bolt size and bolt length. We will judge this degree. That is turn off nut method. Now, twist off type tension control method. This we will use for only TC bolts, not for heavy hexagonal bolts. In TC bolts, I already said you in part 1 session, there is a spline. Okay, spline. So when you insert a TC gun, one holder will hold the nut and one holder will hold the spline. First, nut will rotate in this way. Once nut is completely rotated and bolt achieves its full capacity, then this spline will rotate in opposite direction. Then this spline will be twisting off. So this type of tightening is called twist up type TC bolt tightening. I'll share a video in the description below. In that animated video, it will show clearly how this twist up type tension control bolt tightening will work. Okay. And now calibrated wrench installation. This is very simple. You know this bolt capacity to be achieved after tightening the bolt. The same bolt capacity you will make a reading in the wrench and you will tighten the bolt. So the wrench will automatically tighten the bolt until the bolt achieves its calibrated capacity. Then they will remove the wrench from the bolt. So this is called calibrated wrench installation. Means based on the required bolt capacity, we will directly set the meter and we will apply the wrench. So the wrench will tighten the bolt until exactly that bolt matches its capacity. Now DTA washers. While using DTA washers, there are actually 4 conditions. First, I will say you how a DTA washer will looks like. DTA washer will looks like this only. Means as same as hardened washer. But in this DTA washer, there will be protrusions like this. Okay. Like this. And these portions will be filled with some indicator. When you keep the washer and then when you keep the nut, after tightening, this indicator will come out of this path showing that bolt is fully tightened. So that is the reason why we call it as direct tension indicators. Now there are 4 methods of placing DTA washer. So this method we will use in case of hollow bolts, or when we are applying bolt to HSS surface, you can able to insert the bolt but you can't able to tighten the nut because HSS is a hollow member and inside surface of HSS you can't access. These protrusions are there, right? These protrusions are very delicate. So the main formula what we will say is a bolt can be tightened by rotating head or by rotating nut. Whichever you are rotating, this DTA should not be in direct contact with this rotating object. That is the main fundamental. Based on that, we have divided 3 combinations. One is when you are tightening the nut, below the nut there will be a standard washer and DTA washer will be on head side of the bolt. Okay, that is one condition. And another condition, when you are tightening the nut, you can't able to see the bolt head while tightening. Then you need to provide the DTA washer on the nut side only. In that case, you will provide DTA washer first, then a standard washer and then nut, and you will rotate the nut. So nut is the rotating object and standard washer is in direct contact to the nut, not DTA washer. Okay, and this procedure you will rotate head or nut, whatever. You will provide a standard washer just below the head, you will provide a standard washer just below the nut, and you can use DTA either on nut side or on head side, wherever you want, because you have used already 2 standard washers. So when it comes to hollow bolts, for sure below the nut you need to keep one standard washer. After that, one DTA washer. So these are the combinations in DTA washer usage. And one more thing is, we have discussed that bolt grades are A325 and A490, right? And F1852 is equivalent to A325 and F2280 is equivalent to A490. This A490 will not be available as galvanized bolt. Only A325 will be available as galvanized bolt. Why? Because due to the chemical composition while molding this bolt will lose its strength properties at high temperature. When you are preparing galvanized bolts, the bolts will be immersed in the hot molten zinc which is at high temperatures. At that high temperature, A490 bolt will lose its strength properties and the bolt will be brittle. So that is the reason why A490 bolt will not be available in galvanizing. In the same way F2280 also. Next, minimum and maximum number of bolts. If you take a beam like this, okay, this is the flange thickness and this portion is rounding radius portion, means curved portion, and this is the beam center line, and after this curved portion you will start providing bolt rows. Okay, the minimum number of bolts means your bolt rows, when you are providing these bolt rows, at least one bolt should cross the center line of the beam. So that is the purpose of minimum number of bolts. And when it comes to maximum number of bolts, we already said this is the flange thickness, this is the rounding radius. In the same way bottom also, this is the rounding radius and this is the flange thickness. This is the clear depth available for us to provide the bolt rows, right? This clear depth. So with 3-inch spacing, how many bolts you can provide in this clear depth, that we will say maximum number of bolts. These are the tables which we will use for minimum and maximum number of bolts based on beam depths. Okay, for W6 beam, minimum number of bolts is 1, maximum also 1. For W8 and W10, maximum number of bolts is 2. For W8, W10 and W12, minimum number of bolts is 2. But for W12, if you observe, minimum number of bolts is 2, but the maximum number of bolts is 3. So that is the reason why, based on the clear depth of the beam, we will judge the maximum number of bolts, and based on the concept at least one bolt should cross the center line of beam, we will provide minimum number of bolts. Okay. So that's all for now in bolt session, guys. We'll see you in next session. My next session will be on steel to concrete connection.